What if I told you there's a planet in our solar system that doesn't spin like the others? A planet that rolls through space like a sideways bowling ball. A world where a single day can stretch into decades of sunlight and darkness. That planet is Uranus. It's one of the most misunderstood worlds in our solar system. People often hear that it wobbles, that it spins wrong, or that it somehow behaves unpredictably. But the truth is far more fascinating and far more violent than most people realize. Uranus sits about 1.8 billion miles from the Sun, making it the seventh planet in our solar system. It belongs to a category known as ice giants, along with Neptune. Unlike the gas giants like Jupiter and Saturn, Uranus is made largely of icy materials, water, ammonia, and methane, compressed under extreme pressure. That methane is what gives the planet its pale blue-green color, making it one of the most visually distinct planets we know. But none of that is what makes Uranus truly unusual. What makes it stand out is its tilt. Most planets spin like upright tops. Earth, for example, tilts about 23.5 degrees, which is why we have seasons. Even extreme cases like Mars or Saturn still resemble that general upright spin. Uranus doesn't. Uranus is tilted about 98 degrees. That means it's essentially lying on its side as it orbits the Sun. Instead of spinning like a top, it rolls, like a wheel moving along a track. If you could watch it from a distance, it wouldn't look like a typical spinning planet at all. It would look like something completely out of place. And that single fact changes everything about the planet. Because of this sideways orientation, Uranus experiences the most extreme seasons in the entire solar system. The planet takes 84 Earth years to complete one orbit around the Sun. That means each season lasts about 21 years, but it gets even more extreme than that. For nearly half of its orbit, one pole of Uranus is pointed almost directly at the Sun. That pole experiences constant daylight for around 42 years. No sunsets, no nights, just continuous sunlight. At the same time, the opposite pole is locked in complete darkness for those same 42 years. Then, as Uranus continues its orbit, the situation reverses. The pole that was in darkness slowly rotates into sunlight, and the one that had constant daylight fades into decades-long night. There is nothing else like this anywhere in our solar system. Naturally, this raises the biggest question of all. What could possibly cause an entire planet to end up like this? The answer likely goes back to the earliest days of the solar system, more than 4 billion years ago. Back then, the solar system wasn't the stable place we see today. It was chaotic. Young planets were still forming, and massive objects were constantly colliding with one another. Scientists believe that Uranus was struck by a huge object, possibly one or even multiple bodies roughly the size of Earth. But this wasn't a direct head-on collision. It was more like a glancing blow. Imagine a spinning sphere being struck from the side. The impact doesn't destroy it. It redirects its rotation. That's likely what happened to Uranus. The collision transferred enough energy and angular momentum to tip the entire planet over, leaving it permanently tilted. Some models suggest a single massive impact. Others propose several smaller impacts that gradually pushed Uranus onto its side. Either way, the result is the same, a planet that never returned to an upright position. And once that happened, everything else about Uranus followed from that moment. Its rings, for example, are completely different from what you might expect. While Saturn's rings lie flat along its equator, Uranus's rings are oriented vertically relative to its orbit around the Sun. They circle the planet in alignment with its extreme tilt, making them appear to stand upright. Its moons tell a similar story. Uranus has 27 known moons, and they all orbit along its tilted equatorial plane. This strongly suggests that after the impact, debris formed a disk around the planet, eventually clumping together to form the moons we see today. In other words, the moons themselves may be a direct consequence of that ancient collision. But the strangeness doesn't stop there. Uranus also has one of the most unusual magnetic fields in the solar system. On Earth, the magnetic field is generated by movements in the molten iron core, and it's relatively aligned with the planet's rotation. That's why compasses work in a predictable way. On Uranus, the magnetic field is tilted about 59 degrees relative to its rotation axis, and it's not centered inside the planet. It's shifted off to one side. This creates a lopsided, constantly shifting magnetosphere that behaves in unpredictable ways as Uranus rotates. Instead of a neat, symmetrical magnetic bubble, Uranus has something more like a distorted, wobbling field that twists and changes orientation over time. Scientists think this may be because Uranus doesn't have a traditional, well-defined core like Earth. Instead, its interior is likely a dense, hot mixture of water, ammonia, and methane, sometimes described as a kind of superheated, icy fluid.
This unusual structure could be responsible for generating such an off-center magnetic field. Now, you may have heard people say that Uranus wobbles. In reality, all planets experience something called axial precession, a slow, gradual shift in their orientation over time.
Earth does this too, but very slowly and subtly. Uranus appears more dramatic simply because its tilt is so extreme. Small changes in its orientation can look much more noticeable. Gravitational interactions with its moons and leftover debris from past events may also contribute to slight variations in its motion. But the key point is this: Uranus is stable. It's not currently tipping over further. It's not spiraling out of control. It just looks strange because of what happened to it billions of years ago. At first glance, Uranus also seems calm, almost featureless compared to the dramatic storms of Jupiter or the striking bands of Saturn. But that calm appearance is deceptive. Uranus does have weather. In fact, it has some of the fastest winds in the solar system, reaching speeds of over 500 miles per hour. Massive storms can form, especially during seasonal transitions, when sunlight begins to hit regions that have been in darkness for decades. The reason we don't see as much activity is because of a haze layer in its atmosphere that hides much of what's happening below. Beneath that smooth, pale exterior is a dynamic and active world. Despite everything we know, Uranus remains one of the least explored planets in our solar system. Only one spacecraft has ever visited it, Voyager 2 in 1986. That flyby lasted only a few hours, but it gave us our first close-up look at this strange planet. Since then, most of what we've learned has come from telescopes. And there are still major mysteries. What exactly hit Uranus, and how big was it really? Why does Uranus emit so little internal heat compared to Neptune, which is similar in size and composition? What's happening deep inside its atmosphere, far below the clouds we can see? Scientists are planning future missions to return to Uranus because studying it could unlock answers not just about our solar system, but about planets across the galaxy. Because here's the bigger picture. If Uranus could be knocked onto its side by a massive collision, then similar events are likely happening all over the universe. There could be planets with even more extreme tilts, more chaotic rotations, even stranger climates.
Uranus isn't just an oddball. It's evidence of how violent and unpredictable planet formation can be. It's a reminder that the solar system we see today is the result of billions of years of collisions, chaos, and survival. Uranus took a hit that changed everything, and it's still here, rolling silently through space, carrying the history of that moment with it. And that's what makes it so fascinating. If you want to keep exploring the strangest, most mind-bending stories in science and space, make sure to subscribe to Infinite Science. Because the deeper we look into the universe, the more we realize how little we truly understand.